Hello Math 45 students, this is your instructor Cindy Enrique. We're going to continue on chapter 6 and we are starting on page 6 for section 6.2. We talked about exponential functions in section 6.1 and now we're going to be talking about graphs of exponential functions. So here are some characteristics of the exponential function. We know that it's a one-to-one function. The horizontal asymptote is y is equal to 0. The domain is negative infinity to infinity. The range is 0 to infinity. The x-intercept is none, so there's an asymptote. The y-intercept is 0, 1. It's increasing if b is greater than 1, and it's decreasing if b is greater than 1. So that's that. So now that we kind of have a general feel for our graphs, let's go ahead and dive in. So it says graph f of x is equal to 4 to the x. What is the domain, range, and asymptote? So so the first thing I want to do is I want to graph this function. So in order to graph this function, I can do this on my calculator. Oops. So graph f of x is equal to 4 to the x. So what you can do is you can do this on your calculator. So on calculator, the first thing you want to do is go to the y equals. Once you go to the y equals, you're going to input the y is equal to 4x, okay? So it says like y1, and you can say it's 4 to the x power. Then you press the button graph. And then you can kind of see an outline of the graph. The next thing that you might want to do is actually see the table. So to see table of values, maybe you want to see your x and y values, you're going to go to second table. And once you do that on your calculator, you see some actual points. So here you have 0, 1, you have 1, 4, you also have 2 and 16. So that means your numbers are getting very, very big. And that was not a 6, but a 16. So I'll try that again. 16, there we go. So our numbers, when we start going negative, it becomes smaller and smaller. That's a 0.25. If I were to do -2, that's a 0.0625. So it's getting smaller and smaller. So it looks like my points, let's see, are 0, 1, and then I have a 1, 4, and then I have a 2 to the 16, so that's really high. But -1 and 0.25, that means it's getting closer and closer. So that means, that kind of tells us that there is an asymptote. The asymptote means that it's never going to cross that x-axis. So it's right along the x-axis. So my graph more or less has this type of shape, which is what you can see on the graphing calculator as well. So when it's talking about the domain, I can say that the domain, so that's where all of my x values. So my x values go from negative infinity to positive infinity. So don't forget that these are talking about my x values. The next thing they're talking about is the range. So the range is going to be the y values. So the smallest y value that I have here is 0. And it goes off to positive infinity. And then the last thing I'm going to have is the asymptote. So if I have the asymptote, we know that none of these values for y get negative. Even if I were to do x to the -100 or x to the 1,000,000th, it's going to be something really, really small, like 0.00000000001, let's say. But it never becomes negative. It just gets closer and closer and closer to the x-intercept. So that means my asymptote gets closer and closer to 0, but never actually gets there. And of course my that's my asymptote. So then my asymptote is going to be the y is equal to 0, or better yet, you can say it's the x-axis. Both of those mean the same thing. Okay, so now let's go on to our next example. So here it says we'll be working with transformations of exponential functions as well. So remember how we did the plus means go up and the minus goes down. So that's what we're kind of dealing with here. So we have a horizontal shift. That means if it is a addition, you go up. If it is subtraction, you go down. So let's put these into play. So it says to graph this function, f of x is equal to 2x plus 1 minus 3. What is the domain, range, and asymptote? So from here, we can also put it into the y equals on your calculator. So graph on calculator. And so when I graph it on my calculator, I'm going to have 2 to the power of x plus 1, and I have minus 3. And maybe what I want to do is maybe find some points. So I'm going to go to my second table so I can find some points that I can go ahead and graph on the table that I feel comfortable graphing. So some points here is, let's see, we have 0, -1, that's always a good point to start. I have 1, 1, I have 2, 5, but once I get to 3, it goes up to positive 13, so that's too high. So if I go to, let's say, -2, then, or let's say -1, sorry there, let's have some, and it doesn't really matter, it just kind of depends on how many you need before you see a pattern. So I'll just start with -1. If I were to start with the x value of -1, I get -2. If I go to -2 for my x value, I get a -2.5. If I go to -3, I go to a -2.75. And let's see, if I were to go to a -9, I get to a -2.996. So it looks like I never actually get to -3. So, and also this -3 tells me that the asymptote would have been at the y-axis, or sorry, the x-axis, so it's moving down 3. So at -3, I have my asymptote. And you can also see that by the values. Okay. And now I get to kind of just plot these points. So I'm going to have 0, -1. There's 0, -1. I have 1, 1. I have 2, 5. I have -1, -2. I have -2, -2.5. So they're just getting closer and closer and closer. So my graph more or less looks like that. So now I can tell you about the domain. That goes from -infinity to positive infinity. I can tell you about the range. The range goes from -3 to positive infinity. And my asymptote here is going to be that y is equal to a -3. Okay. And in case you guys needed another example of graphing, it is going to be down below. So again, I'm going to go to my y equals, and I'm going to put in the equation 4 to the power of x minus 2, and I have plus 3. So when I graph it, I have my visual, and I can see what's happening, and I can also do my table to help myself out so I can see all of the values that I'm going to get. Okay, so I have found some values that I can use here. And remember, you just use as many as you need in order to make your case. So it looks like I have 3 and 7. I also have 2 and 4. I have 1 and a 3.25. I have a 0 and a 3.0625. And if I were to do -1 or -5 or even -6, it gets closer and closer to 3, but not really close to 3. And actually we can see that because this is a +3, that's where our asymptote is going to be. So it keeps getting closer and closer to 3, but never ever reaching it. So now I know exactly what my asymptote is going to be. Alright, so now when I plot these points, I'm going to have 3, 7. I have 2, 4, and a 1 and a 3.25, so that's about here. So that's what my graph more or less looks like. So when it's asking for the domain, I know that my domain still goes from -infinity to +infinity. If I'm thinking about the range, those are my y values. So now my y value, it starts at 3 and it goes off to +infinity. And we already talked about the asymptote as well. Okay. So let's go on and talk about our vertical stretching and compression. So our vertical stretch, we can see an example of it, as well as our vertical compression. So here, the vertical stretch is that 3 versus the compression is 1/3. And you're thinking like, what the heck does she mean by the stretch and the compression? So stretch, you can think of it as it getting taller. And the compression, you can think of it as it getting smaller or shorter. Okay. Reflection about the x-axis, that's when we're going to have the negative out in front of it. And reflection about the y-axis, that's the negative in front of the x-axis. Okay, so we have to make sure that we keep those two really clear. Okay, so we want to graph this function now. And again, you guys always have your graphing calculator. So you can say 4 parentheses, and now you have your fraction. And your fraction is the 1/2 that you're going to plug in. And you'll make it to the power of x. So when you press graph, you can see what that graph is going to look like. So since there wasn't anything that you're adding or subtracting, and from the graph on your calculator, you can see that your asymptote is really y = 0, or the x-axis. So I'm going to say that my asymptote is going to be y = 0, or better yet, the x-axis. Okay. So if I wanted to graph this, maybe if I have some points, that might help me to figure out where to put my points exactly. So let's see. I'm going to have the points that are going to help me out. So 0, I always like to start off with 0, 4 is good. I have 1, 2. I have a 2, 1. I also have a -1 that goes to a +8. And I have a -2 that goes off to a +16. So as my y values get more and more negative, then my y values get more and more bigger. Okay, so that's something nice to know. So now I know kind of my general outline. So I have a 0, 4, a 1, 2, a negative 1, 8, and a negative 2, 16. So I know the shape of my exponential. So if I'm talking about the domain, that's all of my x values. So it goes from negative infinity to positive infinity. I have my range, which is my y values. My y values, the smallest y value that I have is 0, because that's the asymptote. It cannot cross that asymptote, but it gets really, really close to it. So that's why it's 0. And then the biggest y value, the maximum y value, is a positive infinity since it shoots up. And I already have my asymptote, which is my y is equal to 0. Okay. So for this one, I notice that there's a negative here out in front. So that negative out in front tells me that this is going to be a reflection across the x-axis. And the reason I know that is from, where is it? Is from here. So this is the reflection along the x-axis. The negative is out in front. Okay. So I know this is going to be kind of reflected. And I know what this is going to look like. So I'm going to go ahead and have my values that are going to help me to graph some particular points on this graph. And without even graphing it on my calculator, I already know what the asymptote is going to be. Since there isn't any plus or minus behind the fraction, I know that the standard asymptote for any exponential is going to be my y equal to 0. So I'm going to go ahead and say that my asymptote is going to be y is equal to 0, or better yet, the x-axis. Okay. So now if I find some values for this graph, I can see that the graph, if I start at 0, I have a negative 4. If I have a positive 1, it's a negative 1. If I go down to a positive 2, now I'm start dealing with a negative 1/4. So now I know my values are getting closer and closer to 0, but never quite getting there. So what happens when I plug in my negative values? Well, if I plug in a negative 1, that's a negative 16. So I'm like, okay, at least now I have a general idea of what this graph is supposed to look like. So I know that I have a 0, negative 4. I have a 1, negative 1. And a positive 2, it's a negative 1/4, so it's like really close. And at negative 1, it shoots off to a negative 16, so you're somewhere over here. So your graph, more or less, is looking like that. So now I can tell you my domain, that's my x values. So my domain is going to go from negative infinity to a positive infinity. I can tell you my range, my y values. The smallest y value here is a negative infinity, and the biggest y value is a 0. And I already have my asymptote. Okay. So now you have some description. So hopefully this is somewhat familiar from a previous chapter that we had. So it says the function y is equal to fx is vertically stretched by a factor of 6, reflected across the x-axis, and then shifted up 1 unit. Find the resulting function. So this is something that you can't really plug into your calculator. This is one where you really have to know your definition. So this is what I like to do. I know that my start or my initial equation is given to me, and that's that y is equal to 5x. I'm going to go ahead and write that. So y is equal to e to the 5x. So now let's just go by what each thing has said. It says it's vertically stretched by a factor of 6. So I know that it's a vertical stretch by 6. So what that tells me since it's a vertical stretch, and if you need to see it, I know I have my descriptions up above. So here I have a stretch. See how that's a stretch? So that means I'm going to have that 6 in front. So that tells me I'm going to have y is equal to 6e5x, okay? All right, now let's look at the next thing. It says it's reflected across the x-axis. So reflected across the x-axis. So again, if you need to understand where that is, that reflected across the x-axis, if I look at that definition over here, let me go ahead and erase this. So reflection about the x-axis, it's this one. So I know that the negative is going to go out in front. So I'm going to have that y is equal to a negative 6e to the 5x. Okay? And the next thing it says it's going to be shifted up 1 unit. So, okay. So up 1. That tells me I'm going to have a plus 1. So y is equal to a negative 6e to the 5x plus 1. And that is going to be my final answer. There isn't any more to do. So we're going to keep doing that until we find some consistency in the language. So let's try another problem. So it says if the function y is equal to e to the negative 3x is vertically compressed by a factor of 4, then reflected across the y-axis and shifted down 5 units, what is the resulting function? Again, you want to start by identifying your original function. So I know that what I start with is going to be my y is equal to e to the negative 3x. So the first thing that's going to happen, and that's why not use different colors, is that it's going to be vertically compressed by a factor of 4. So I know I'm going to be vertically compressed. So I'm getting smaller by 4. So what that tells me is that I still have y is equal to, but now since it's a compression, I'm going to have 1/4. And I still have my e to the negative 3x. The next thing that I'm going to have is then reflected across the y-axis. So okay, so reflected across the y-axis. So that means I'm going to have that y is equal to my 1/4 e. Now it's going to be a negative. And let's keep consistent with my color coding. So it's a negative in front of my negative 3x. So you're like, wait, a negative times a negative is a positive. That is correct. So I really have that y is equal to a 1/4 e positive 3x. All right. So now the third thing here, let's go ahead and do this in, I guess, purple. It says then I want to be shifted down 5 units. So shifted down 5. So I'm going to have y is equal to my 1/4 e to the 3x. And since it's down 5 units, that's going to be a subtraction, minus 5. And so that's going to be my final answer there. So you really have to understand the English and the translations, okay? So if you guys have any questions, you guys are free to email me at any time. I'll try to get back to your emails within 24 hours. And also you can contact the Math Success Center. They have free online tutoring. Okay, thank you.